Imagine standing on the surface of Mars. The red dust swirls around you, the sky has a faint, eerie glow, and the temperature is a bone-chilling 80-degree Celsius. There's no breathable air, no liquid water, and deadly radiation seeps through the thin atmosphere. Yet some scientists believe that one day humans could walk freely on Mars without spacesuits. But how? Could we actually terraform Mars and turn it into a second Earth? And if we could, should we? Mars has fascinated humanity for centuries, from ancient civilizations mistaking its red hue for an omen of war, to modern scientists exploring its potential as our future home. With Earth's growing environmental challenges, the idea of making Mars habitable seems more urgent than ever. But terraforming isn't just science fiction. It's a massive scientific and engineering challenge that may take centuries or even millennia to accomplish. Before we jump into the possibilities, let's first understand what makes Mars so inhospitable, and why terraforming it is such a daunting task. The harsh reality of Mars, unlike Earth, Mars has a very thin atmosphere, about 100 times thinner than ours. This means it can't retain heat, so temperatures plunge to extreme lows. But that's not the only problem. Mars' atmosphere is 95% carbon dioxide, with barely any oxygen. On top of that, without a strong magnetic field like Earth's, Mars is constantly bombarded by deadly cosmic radiation, making long-term human survival nearly impossible. There's also the issue of water. While evidence suggests Mars once had rivers, lakes, and even oceans, today almost all its water is either frozen underground or locked in ice caps. Without liquid water, supporting large-scale life is nearly impossible. And then there's the dust, fine electrostatically charged particles that could clog machinery and pose serious health risks for future settlers. So, if Mars is such an unforgiving wasteland, how do we even begin to think about making it habitable? Scientists have proposed a variety of ideas, some more realistic than others. Let's explore the leading theories on how we might terraform the red planet. Warming up Mars. The greenhouse effect, one of the biggest obstacles to making Mars habitable, is its freezing temperature. To change that, we'd need to warm up the planet, and one way to do that is by enhancing its greenhouse effect. On Earth, greenhouse gases like carbon dioxide and methane trap heat from the sun, keeping our planet warm. Mars already has CO2 in its atmosphere, but not enough to make a difference. One proposal suggests releasing massive amounts of greenhouse gases into the Martian atmosphere to trap more heat. This could be done by triggering the release of CO2, trapped in the planet's polar ice caps. Some scientists have even suggested setting off nuclear explosions to release this gas quickly. However, research indicates that Mars simply doesn't have enough CO2 to make this method effective on its own. Another idea is importing greenhouse gases like methane from other sources, such as Saturn's moon Titan. But the logistics of transporting vast amounts of gas across the solar system make this idea incredibly difficult, at least with our current technology. Creating an artificial magnetosphere. Even if we manage to warm up Mars, the lack of a magnetic field remains a critical problem. Without one, the sun's solar wind strips away the atmosphere, preventing Mars from holding on to any changes we make. Some scientists have proposed creating an artificial magnetosphere, essentially a giant magnetic shield that could protect the planet. NASA researchers have suggested placing a powerful magnetic field generator at Mars's L1 Lagrange point, a stable orbit between Mars and the Sun. This artificial magnetosphere could block harmful solar wind and allow Mars to slowly regain its atmosphere. While this idea is theoretically possible, the energy and resources required to build such a structure would be enormous, making it one of the most ambitious engineering challenges in human history. Importing or producing oxygen, breathing on Mars, is another major hurdle. Even if we create a thick atmosphere, we still need oxygen. There are a few potential ways to generate it. One method involves using electrolysis to split water into oxygen and hydrogen. But since liquid water is scarce, this would require either melting vast amounts of ice or importing water from other celestial bodies. Another idea is biological terraforming, introducing special microbes or genetically modified plants that can produce oxygen through photosynthesis. Some bacteria on Earth thrive in extreme conditions and could potentially be engineered to survive on Mars. However, this process would take thousands of years before oxygen levels became high enough for humans to breathe without assistance. So with all these challenges, is terraforming Mars even possible? Scientists are still debating the feasibility of each method, but there's no denying that making Mars habitable would be one of the greatest achievements in human history. But even if we could terraform Mars, should we? Would altering another planet come with unforeseen consequences? And is there a better way to ensure humanity's survival without reshaping an entire world? Let's dive deeper into these ethical and practical dilemmas in the next section. The ethics of terraforming Mars. Should we really do it? Imagine humanity has finally mastered the art of terraforming, and Mars has been transformed into a livable planet. Cities rise from the red dust, fields of green stretch under a blue sky, and people walk on the Martian surface without space suits. It sounds like a dream come true, right? But before we get carried away with this vision of a new home for humanity, we must ask ourselves, is it ethical to terraform Mars? Mars has never supported life in the way Earth has. Its ecosystem, if you can call it that, is barren, and there are no known forms of life on the surface. But what about the possibility of microbial life existing beneath the surface, in Mars' icy depths, or in the subsurface brines? Some scientists believe that Mars may harbor life, but it's hidden deep beneath the surface. If that's true, then terraforming could destroy an entire ecosystem, one that we haven't even discovered yet. In this light, terraforming could be seen as an act of colonialism, where we destroy what little might exist in pursuit of human gain. Additionally, terraforming Mars may be seen as an irresponsible act of environmental manipulation. On Earth, we have already witnessed the disastrous consequences of unchecked industrialization and environmental degradation. Climate change, pollution, and the destruction of natural ecosystems have had profound effects on our planet. By attempting to remake Mars into something it's not, could we be repeating the same mistakes? Instead of focusing on transforming another planet, shouldn't we focus on fixing the environmental damage we've caused on Earth first? Some argue that terraforming Mars is our backup plan, a way to secure the survival of humanity in case Earth becomes uninhabitable due to catastrophic events like climate change, war, or asteroid impacts. But is it wise to invest so heavily in terraforming another planet when there are pressing issues right here on Earth that need our attention? Terraforming could take centuries, if not longer, to achieve. And in the meantime, what will happen to the millions of people who live on Earth? On the other hand, the potential benefits of terraforming Mars are enormous. By establishing a human presence on Mars, we could develop new technologies, expand our knowledge of space, and create a backup for humanity in case Earth's resources are depleted or our planet faces an existential threat. In a way, Mars could be our insurance policy against the unknown, a stepping stone into the cosmos. Technological challenges and the timeline of terraforming. When it comes to the actual process of terraforming, we're still in the realm of science fiction. While the ideas we've discussed, warming the planet, creating an artificial magnetosphere, and generating oxygen, are based on real scientific theories, the technology to carry out these plans doesn't exist yet. Some of the ideas, like releasing greenhouse gases into the atmosphere or constructing a magnetic shield, require technologies that are still in their infancy. For example, we currently don't have the technology to generate or store enough greenhouse gases to make a significant impact on Mars' atmosphere. The proposed methods, such as nuking the polar ice caps, are theoretical and highly controversial. Even if we could create a magnetic shield, the energy required to build such a structure would likely exceed anything humanity has ever achieved. And the creation of a breathable atmosphere, whether by biological or mechanical means, would take millennia. But that doesn't mean it's impossible. Human ingenuity has always found a way to overcome challenges. The Apollo missions, which once seemed like an impossible dream, became a reality. The technological advancements we've made in space exploration, like landing rovers on Mars and building the International Space Station, prove that nothing is truly out of our reach. While terraforming Mars may be centuries away, it's not entirely outside the realm of possibility. The case for focusing on Mars colonization. Instead, while terraforming Mars may be the long-term dream, there's an alternative path that could allow humans to thrive on the red planet without radically altering its environment: Mars colonization. Instead of transforming Mars to fit Earth standards, we could adapt to the Martian environment. Colonization, as opposed to terraforming, involves creating self-sustaining habitats on Mars that could support human life in the short term. We could build domes or underground cities with controlled environments, providing oxygen, water, and food for astronauts and settlers. With the right technologies, humans could live on Mars in the same way we've managed to survive in extreme environments on Earth, such as Antarctica or underwater research stations. In fact, several private companies, including SpaceX, are already working on the technology to make Mars colonization a reality. Elon Musk's vision of sending humans to Mars within the next few decades is ambitious, but not impossible. He believes that establishing a permanent human presence on Mars is essential for humanity's survival, and he has proposed building self-sustaining colonies that could one day grow into large cities. While Musk's timeline may be optimistic, the technological groundwork is being laid. The advantage of focusing on Mars colonization over terraforming is that it could be achieved in a much shorter time frame. Instead of waiting centuries for Mars to become Earth-like, we could start building human settlements within the next few decades and gradually adapt the Martian environment to our needs without fundamentally changing the planet itself. Conclusion. The future of Mars. So, what's the verdict? Can we terraform Mars? In theory, it's possible, but incredibly difficult and time-consuming. The scientific and technological challenges are immense, and the ethical dilemmas we face could make the process even more complicated. Terraforming. Mars might be humanity's ultimate challenge, but is it the right challenge to pursue? Should we focus on adapting to Mars instead of trying to remake it in our image? Or should we shift our focus to solving the environmental issues we face here on Earth, rather than venturing too far into space? Mars is a tantalizing mystery, but as we look toward the stars, we must remember, the choices we make today will shape the future of humanity, on Earth and beyond. What will we choose? Will we make Mars our second home, or leave it to remain untouched, a distant world that reminds us of our limits and our responsibilities? The path forward, humanity's role in the cosmos. We continue to gaze upward at the red planet. The question of whether we should terraform Mars or simply colonize it remains complex. It's a question that bridges science, technology, ethics, and even our very sense of identity as a species. Mars may not be a hospitable place today, but the desire to turn it into a second Earth is a testament to humanity's relentless spirit of exploration and innovation. Terraforming Mars, if it ever happens, could take centuries and possibly millennia. The road to transforming Mars into a thriving, Earth-like planet will be long and fraught with obstacles. Yet as we stand on the edge of these monumental challenges, there's no doubt that the technologies developed in pursuit of terraforming could lead to incredible advancements in other fields. The pursuit of a livable Mars could push our understanding of space travel, environmental engineering, and even the future of life on Earth. However, we must also be mindful of the potential consequences of such monumental undertakings. While we look to Mars as a potential escape from Earth's problems, we must ask ourselves, are we simply repeating the same mistakes that led to environmental damage here? As we strive to make Mars habitable, could we be ignoring the urgent need to fix the planet we already call home? Maybe, just maybe, the true test isn't whether we can terraform Mars, but whether we can learn from our experiences on Earth and ensure that we don't repeat the same mistakes elsewhere in the cosmos. Could Mars be humanity's next step, or would it be wiser to fix the place where we already live before venturing too far? As we look forward, the idea of a multi-planetary future is undeniably exciting. We might not terraform Mars tomorrow, but that doesn't mean we should stop asking, what will it take to make Mars, or any other planet, our next home? How far are we willing to go, and what will it mean for the future of humanity? In the end, whether Mars remains a red, barren world or blossoms into a new Earth is up to us, and the choices we make today will echo far beyond the confines of our planet, guiding humanity into the stars. So, as we wrap up our exploration of terraforming Mars, consider this. Could our future as a species truly lie on another planet, or should we focus on preserving the world that has already given us so much? And what role will we play in that future? Let us know your thoughts in the comments below. Could Mars one day be our second home? Or do you think we should turn our attention back to Earth before venturing out into the universe? Let's keep this conversation going.